Hey guys, Dr. Brown here, and tonight, you Calculus 2 fans out there, we're going to be looking at proving that the integral of sine x parentheses raised to the nth power equals all of this stuff here. So hey, let's get after it. All right, one of the ways that it's, at least in my experience, that to work these, let's take and break this integral into two pieces. So let's say sine x, I'm going to take parentheses n minus 1, and sine x to the first power. Now you know if we multiply these together, we add the exponents. N minus 1 plus 1. The ones cancel and you end up with just sine x raised to the nth power. So let's do that. And now then, let's put together a DI integration by parts. And you always want to pick the item that you can integrate is your first choice. Which one should I integrate? Hey, sine x, I know I can integrate that puppy. All right, so let's put it here, sine x dx. And then the other term, sine x to the n raised to the n minus 1. So let's go ahead and integrate this one. Bring down the n minus, differentiate this one. Bring down the n minus 1. Sine x now to the n minus 2. Chain rule. What's on the inside now? Derivative of that. Derivative of sine is cosine x. Okay, the integral of sine x, the derivative is of sine is cosine, the integral is negative cosine x. Okay, so now we know we're going to multiply that diagonal, and then we're going to integrate that row. I think I can integrate that row, so that's why I'm stopping there, okay? So we have the integral of sine x to the nth power dx equals, we've got a positive and a negative, so let's see, we have sine x to the n minus 1 and a negative, and they put that here, cosine x, and then negative, so plus the integral, and I always do that, plus n minus 1 times the integral of sine x to the n minus 2, and then cosine times cosine, it's cosine squared x dx. Got a little sloppy there. Cosine squared x dx. All right. What to do now? Well, let's take this cosine squared and let's change that to 1 minus sine squared and then multiply it out. So I'm going to work with that for just a moment. So we have plus n minus 1 times the integral of sine x to the n minus 2, and then changing that cosine squared into 1 minus sine squared. Okay, still have our dx here. Now let's distribute that. So n minus 1, the integral of sine x to the n minus 2 times 1. Sine x to the n minus 2. I'll separate it into two integrals. Now, sine x to the n minus 2 times a negative is going to give me a negative, so it's n minus 1 integral of sine x to the n minus 2 times sine x, and that's raised to the second power, dx. All right, so you'll notice here sine x to the n minus 2. I'm multiplying these two terms together, n minus 2 plus 2. The 2's cancel, and this just becomes sine x to the n. So it becomes this. Okay, let's catch up now with everything else. So we have the integral of sine x raised to the nth power dx equals sine, bringing these terms down, x to the n minus 1 cosine x plus all of this. Now, we have sine x to the n, sine x is parentheses to the nth power. Wow, I can add one, n minus 1, because this one's negative. Let me add one here, add one there, and we'll sum all of that up and see what we have left. So sine x to the nth power dx. If I add one here, those cancel. Let me add one here, plus n minus 1, the integral of sine x to the nth power dx. Now I have one of them here, right? So I have 1 plus n minus 1. Everything cancels except for the n. So I have n times the integral of sine x raised to the nth power dx equals sine x to the n minus 1 cosine x plus n minus 1 integral sine x to the n minus 2 dx. The rest of this is gone. Now then, I don't want to know what n of these are. I want to know what one of them is. So I need to divide by n, or multiply by 1 over n. Okay? So n over n, this becomes 1. So voila. Now the integral of sine x to the n dx equals, I'm missing a negative sign. Wow. Oh, there it is right there. I just didn't bring it down. Hopefully you were going, wow, he missed it. He forgot the negative. All right, so it equals negative 1 over n sine x to the n minus 1 cosine x plus n minus 1 over n integral sine x to the n minus 2 dx. Okay, we've just proved that that works out. I would encourage you, if your calculus book is like mine, you can flip open the cover of it, actually the front couple of pages, the cover of the book, then another page. You flip to the back and multiple pages there of just things just like this. And many times I'll grab one of those and say, hey, can I work that? Can I do that? And it builds my skill set. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. That's all for now. Keep studying and we'll talk to you next time. Thanks.